Okay, today we're going to be talking about reference variables. And of all the topics we're going to cover this semester, reference variables and objects are amongst the most important. So I'm going to begin by contrasting primitive and reference variables. So how are they different? How are they the same? Then we're going to look at objects, and we'll look at how do I instantiate an object. We'll take a closer look at what is an object, and then we'll look at how do I operate on an object. In other words, what do I do with objects? So I'm showing here, kind of starting with primitive variables, I'm showing here the definition of a variable. A variable is a memory location that stores a value of a particular type. And that definition is true whether you're working with a primitive variable or whether you're working with a reference variable. I also am showing here kind of this picture of memory. We talked before about how in your computer there are these memory sticks. And if we were to get on the magic school bus and zoom in, we would see that memory is nothing more than an array or a sequence of memory slots or memory locations, and each location can store a value. Each memory slot has a unique memory address associated with it in the same way that houses have mailing addresses. And I have added a little bit to our drawing. I've added this ampersand notation here. Before, when we looked at this drawing of memory, we didn't do much with the memory addresses themselves. But in fact, we're going to see that reference variables are intricately linked with memory addresses. And so to distinguish between a number and a memory address, I've added this ampersand symbol. This is really just my usage. This isn't in Java. In other computer programming languages like C, the ampersand is known as the memory address operator. So I didn't just make it up, but this is not Java. But I wanted to distinguish between the number 1024 and the memory address 1024. And so I'm using the ampersand to do that. Okay, so this is kind of our setup. We know what a variable is. We know how variables interact with memory. Let's just write a very simple line of code and create a primitive variable. Okay, so here's my main method here. And I could say int age equals 20. Okay, nothing new here. On the left-hand side of the equals, we have a variable declaration. The computer will look for an empty memory location, and it will associate that with the variable name, which is age, and it will initialize it to whatever initial value you specify on the right-hand side. So that is the number 20. Okay, so all of that should be reviewed. One thing I want to note, and this is a seemingly obvious statement, but I'm going to make it anyways, and that is that primitive variables store literal values. So if you have a primitive variable of type int, it is storing a literal integer. If you were to go into memory and look, there would be an actual integer. If you had a double, okay, if you were to go into memory, you would see that that variable is storing an actual floating point number. If you had a Boolean variable and you were to look in memory, you would see that that memory location is storing an actual Boolean value, either true or false. Okay, so primitive variables store literal values. Now, this seems like an obvious kind of, okay, sort of statement, but this is really where primitive variables and reference variables differ with one another in what they actually store. So let's look at what a reference variable is. Okay, so we had, right, int age equals 20. We saw what that did in memory. So consider the following code. String name equals Bob. Okay. Let's assume Bob is some person who's 20 years old. Okay, at first glance, these two lines of code look really similar. For both of them, on the left-hand side, we have a variable declaration. On the right-hand side, we have initialization. Here, we're initializing the variable with a numeric literal. Here, I'm initializing the variable with a string literal. So on the right-hand side, we have both literals. But notice that string, right? This is not a primitive type. Oh dear, not. And you should be able to recognize this. String is capitalized. Okay, so it's not a primitive type. String is a class. Let's look at what's happening in memory when we execute this line of code. So again, as per usual, on the left-hand side, we have a variable declaration and nothing really changes there. So the computer will look for an empty memory location. When it finds one, it will associate it with the name of the variable, which is name. But instead of storing the string literal inside of this location, it's actually going to create what's known as an object. So it's going to find some memory. It's going to create an object. Okay, this is a string object. I'm kind of denoting the object with the circle here. And then inside the object, it will store Bob. So that kind of begs the question, okay, well then what is stored here? What is actually stored in the memory location associated with name? And what is actually stored there is the memory address of the object we just created. Okay, so the memory address 1200 gets stored here. This is actually why reference variables are called reference variables, because reference variables do not store literal values. They actually store memory addresses. Another way to say that is that the variable is referencing, or it's referring to a particular object. Okay, so they're called reference variables. Okay, so just to highlight that, primitive variables store literal values, whereas reference variables, oh, that looks awful. Okay. So reference variables store memory addresses, the addresses of objects. So primitive variables store literal values, reference variables store memory addresses of objects, okay? That's it. In some ways, that's it. We could like end the lecture here, not really, but in terms of reference variables, that is what a reference variable is. Okay. What I want you to do is I want you to do two things. The first is I want you to pause the video. You should make sure that you've copied down all of the contents of these slides. I had pre-written a lot, and so you're going to need to copy that down. After you copy it down, I want you to just sit here and think about what I've just said. Okay, so look at this diagram here and how the variable name is actually storing a memory address, 1200. It's storing the memory address of the object, right? And it's the object that stores the actual string. I just want you to sit with that and I want you to think about that. Okay, so that's the first thing. Pause the video, copy down the notes, and just sit here and think about that. You don't have to have deep thoughts, but you should have thoughts. Okay, the second thing I want you to do, I want you to try to answer the following question. Why? So why, okay. What is the benefit of having reference variables? This is really slow. Okay. So I want you to think about that question. Okay, why? Why do this? What's the benefit of having reference variables? What's the benefit of having a variable that stores a memory address? Why even do that in the first place? Okay, so I want you to take some time and just, can you come up with one reason why this might be important or advantageous? Okay, while you pause the video and think about that, I'm going to pause recording if I can because my kid is screaming. So let's pause that. And I will go and check on my child. You pause, think about this question, and then we'll come back. Okay, so I'm back and you're back. Okay, I'm not going to tell you. I'm not going to tell you what the benefit is of having reference variables. Historically speaking, at some point in the development of computer programming languages, people thought, you know what, we really need reference variables. And so they created this idea of reference variables. So there must have been some reason and some purpose. I'm not going to tell you what that is, and this is going to be what we're going to talk about in class. So I'm going to have you get into your groups. And so I want you to come to class with at least one thought. Why? What is the benefit of having reference variables? What do we gain? If the world only had primitive variables, is that not okay? Okay, so come to class with at least one idea of why reference variables are advantageous or what the benefit is, and then we'll get into our groups, discuss it, and I'll try and pull out some sort of cohesion and an answer in class. Okay, so for now, that is what reference variables are. On the left-hand side, it's a variable declaration. On the right-hand side, we initialize it to something, but behind the scenes in memory, it's quite different. Reference variables are storing memory addresses of objects. Okay, the next thing I want to talk about is how are these objects actually being created, because the line of code I'm showing here is slightly misleading. Because we use strings so often in programming, I mean, I basically use a string every time I program in Java. The Java programming language has a lot of shortcuts for when you're working with strings to make your life a little easier. So what I'm showing here, this variable declaration and object initialization here, it's actually kind of a shorthand notation. So we're going to look at the actual syntax. If I wanted to create a reference variable, what is the actual syntax, as opposed to this, which is the shorthand, and it's really just for strings only to make your life easier because you're going to use strings all the time. Okay, so let's look at the actual syntax. So here on the left-hand side, if we wanted to create a reference variable of type string, as we saw, we could do string name equals Bob. You will find, though, for other types beyond string, that shorthand doesn't exist. So here's the proper way that you would actually create a reference variable and instantiate or initialize the object. String name equals new string parentheses Bob. Okay. So you'll notice that the left-hand side is the same. Basically, declaring a variable is declaring a variable. It doesn't really matter if it's primitive or reference type. What changes is the right-hand side. The right-hand side over here is a little bit more complicated. Again, on the left-hand side, it's been on the right-hand side of this left-hand side, it's been simplified just for strings. Okay, so let's kind of decompose and look at this line of code here. So the first thing I want to talk about is the new operator. And the new operator requests memory. Requests. To create the object. What I mean by that is the new keyword actually interfaces with your operating system. It is requesting that the operating system find space somewhere in memory to store this new object. Okay, so later in the semester, we're going to think a little bit more about the new operator in the sense that anytime in your code you use the new operator, you are asking for memory from your computer. And if you're not careful, you can actually slow down and possibly crash your computer. You probably wouldn't crash it because Java has a lot of safeguards in place, but you can actually slow down your computer because truly the new keyword is asking your operating system, hey, I need some memory here. I need enough memory to store this string. Okay, so the first thing that happens is that the new operator requests memory from your operating system in order to create this object. Next, string, open parentheses, closing parentheses, what is it? It has some parentheses. This must be a method, and in fact, it is a method. This is a special method called a constructor. Okay. So string is a special method called a constructor. And the purpose of constructors is to initialize the object. So first the new keyword gets the memory, then the constructor, the special memory, takes that raw memory and it initializes it and creates a brand new object for you. In this case, it's creating a new string object. Inside that object, the string Bob is stored. That's what I mean when I say it initializes the object, right? We want to store the string Bob inside of there. So it stores the string Bob. The return value then of the right-hand side is, and maybe you should stop this video and ask yourself, what must the return value be? What must the return value be? You should stop and just think about that. Okay. The return value of the right-hand side is the memory address. Of the newly created object. So that is the whole process that happens to instantiate an object, okay? In this line of code here, left-hand side, as per usual. It's the right-hand side here. We are explicitly asking for a sufficient amount of memory. The constructor then initializes that. The return value is the memory address. the memory address then gets stored inside of the reference variable. Okay. Okay, so before we look at what do we do with reference variables, so I have one, I know how to create one, but what I do with it. Before we get there, I want to stop and pause a little bit and just talk a little bit more about what is an object, because so far we've talked about objects, but I haven't actually defined or kind of delved into what an object is. I kind of just drew a circle, said this is an object inside lives Bob, and we haven't really gone deeper than that. So I'm going to try and define for you what an object is and define for you kind of the components of an object. But I would say that understanding what an object is a journey that will take you the entire semester. So understanding objects, understanding classes, again, not at a definitional level, but at a, I hate to use the word ideological, but like at a philosophical level, I find is not easy. So I'm going to give you a definition for an object, talk a little bit about what they are, but really it's something that will take you kind of the whole semester to kind of really understand, and that's okay. Okay, here's my definition of an object. What is an object? So an object is a structure that contains data and methods. So inside of this string object that we had stored in memory, we already know what the data is. The data is the string Bob that we initialized, right, the object to. This is the data that lives inside of this object. But more than just data, more than just the string lives inside of the object. There are, in fact, methods that live inside of this object as well. And we're going to talk about that on the next slide. As a preview, one method that lives inside of here is called length. This method takes nothing. It requires no inputs. If you call the method, though, what it will do is return back the number of characters in the data, the number of characters in the string. So if we were to call the method length, it would return back 3. Bob has 3 characters, B-O-B, okay? There are dozens of other methods that live inside of this object, and we can call those methods to do things to the data. One thing I want to state, and again, this is kind of going a little bit deeper, what is the purpose of the data? So the data define the state of the object. This word state here, when I say that the data defines the state of the object, what I mean is that the object can exist in different states. And those states are completely specified by the value of the data, okay? Your book talks about, and I guess we will end up talking about lots of different types of objects, but in this example here, this string object stores the string Bob. I could have another string object that stored the name Annie. Those two strings have different data, meaning they're existing in different states, okay? The methods then allow you to operate on the data. The methods that live inside the object allow you to operate on the object. We'll see that later that there are two different types of methods, broadly speaking. When you look inside an object, you'll find some methods that return information about the state. What is the string that's stored inside of this object? How long is that string? Does that string contain a B? Where is the B? So some of the methods that live in this object allow us to query the data, to ask questions about the data, to get information about the data. Similarly, also, the others, broadly speaking, kind of general class of methods allows us to act on the data, allows us to change, update, or mutate the data, okay? And those are the two types of methods that you'll see. Some give you back information and some actually change the data, which is another way of saying they change the state of the object. Okay, last but not least, together, the data and the methods implement okay, that's just out there. Some conceptual functionality. So together, the data and the methods implement some conceptual functionality. We're actually going to talk much later, so in a few weeks, about how we would write our own objects. How would we create our own objects? And we will see, once we kind of look at the process of creating an object, defining your own type, we'll see that when you create an object, when you define your own type of reference variable, there's kind of a beautiful synergy that happens between the data and the methods. And you'll sit there and you'll think, okay, I need this data. What are the sorts of things I might want to do with this data? What are the sorts of things someone else might want to do? And ultimately what you're doing is you're kind of crafting or creating some sort of functionality that is useful. Okay, so again, as the semester goes on, I think these different bullet points will mean successively more to you. But I want to throw it out there, and then we'll kind of come back to this idea of data and methods and implementing some functionality in a few weeks. But for now, at least, that's kind of an understanding of what an object is. Take what you can take, leave what you don't understand. We'll come back to it. It's all good. Okay. Okay. We have a reference variable, right? At this point, the only type of reference variables we really know how to create are string types. We will look at other types like in the next video lecture. So let's just kind of focus on string types right now. We have a reference variable of type string. If we had a primitive variable, we would know what to do with it. For example, if we had a variable of type int, there are lots of operators we can apply to our variable. The addition operator, subtraction operator, division operator, the remainder operator. Those are all operators that act on the value stored in the primitive integer variable. So correspondingly, the question becomes, well, what can we do with our reference variables? What are the operators that act on the object referenced by this reference variable? What can we do with it now that we have it? Whereas for numerical primitive types like integer, float, double, you have all of the arithmetic operators. Literally for reference variables, there is only one operator. Only one. The end. It is called the dot operator. It is the only operator that you can apply to a reference variable. So let's look at the dot operator, and then we'll look at some code and be done. Okay. So what is the dot operator? So the dot operator The dot operator allows you the quality of my handwriting corresponds to how slow my computer is being, and right now it's being incredibly slow. Okay, the dot operator allows you to access the data and methods. These are also known as AKA members. People will often use the word members to just refer collectively to all the stuff inside the object, the data and the method. Those are members. So the dot operator allows you to access the data and the methods. In other words, it allows you to access the members stored inside the object. Now, this may seem simultaneously confusing. It's not clear what this buys us, and also limiting and restricting. I can only do one thing, which is a dot operator, right? So it's not obvious right now why having only one operator that allows me to touch or access the members is useful. The reason why is going back inside of this string object, there are dozens of methods in there, dozens. Each of those methods allows you to do something unique. It allows you to query the data. It allows you to compute information. So we don't need a bunch of different operators like we did with primitive types, the addition operator, subtraction operator. Instead, that diversity of operators is manifested in the diversity of methods that lives within my object. There are so many methods you could call. So really the only operator we need is an operator that lets me call those methods. They exist inside the object. I want to execute them. I want to call them. So the dot operator, in general, it's not just for methods. In general, it allows you to access members inside the object. Some of those members happen to be methods. And oftentimes, as we'll see when we write our own objects, there's so many different methods that you can call. That's where the diversity comes in. That's where the, there's a word I'm thinking about. It's a word that means all the different things that you can do. Plurality, I don't know, whatever, but that's kind of where the creativity and the variety comes. It's in the methods. Okay, what is a dot operator? It's the dot. Let me move this dot out of the way. The end. The dot operator is actually the dot. It is the period on your computer. We've already seen the dot operator. System. Dot out. Dot print ln. Okay, so we use the dot operator when we print something. Okay, so looking system is a class. I know that because it's capitalized. Inside the class, that's what the dot operator does. It lets you go inside a particular scope, inside out. Inside is an object called out. Inside that object is a method called println. And we can use the dot operator to go inside, inside, inside to access and execute that method. Okay, in the same way, when we have a string object, okay, here. So when we have a string object, there are lots of methods. For example, the length method. We use a dot operator to call those methods. So I'm going to switch to BlueJ and we can look at how do we actually use the dot operator, and we can start looking at some of the methods that are available to you to use inside of the string class. Okay, so here's some code that I wrote. I put a lot of comments in here, basically because this is like part of the lecture. Okay, whatever. Okay, so here's my main method, and inside I'm creating a reference variable. String city equals new string Tacoma. This is creating a new object. Inside that object, the data is initialized to the string Tacoma, and as I said, there are lots of methods. Okay, here are some of the methods that are inside the string class, and here's how you would call them. And don't forget, if a method returns a value, you should probably store that value, or else you cannot use it later. We're going to see all of these things, kind of all the topics we've talked about are coming together right now. Okay, here we go. City is the name of my reference variable, okay? But it is in fact a memory address. I'm applying to that memory address the dot operator, and then I'm calling the length method. This is how you use the dot operator. It is variable name dot method. Hopefully this makes sense to you. We are saying go to memory address 1024 and access inside, that's what the dot operator does, the method called length. Okay, so that's the meaning. In the comments, I'm describing what each of these methods does. So the length method returns the number of characters in the string. Because it returns that, right, when the computer executes the right-hand side, it's a method. When it resolves the method, it gets a number. I am then storing that number in a primitive variable. Okay? I'm not going to tell you what the number is. Okay. You should also, I want you to, as we go through, pause the video and predict what do you think will print out. Okay, so after I call city.length and I store the answer in this variable, and then I print it, what do you think is going to print? Okay, and then you can kind of check your understanding. Note that the type on the left-hand side must match the return type on the right-hand side. This method returns back an integer. Thus, on the left, you must store it inside an integer. You could not call this method, which gives you an integer, and try and store that inside of a string, or inside of a character, a char, or inside of a Boolean. That does not work. Whatever the return type of the method is, that is the type of the variable you must store the answer in. And I am belaboring that point because many of the questions you ask me are going to boil down to that simple fact. All the types have to match. Okay, next method. Inside your string object, there's a method called char at. This returns the character at the specified position. So you pass in the integer, the position, and it will tell you what character, what letter is at that position. The only thing that you need to know is that in computer science, we always start counting at 0. So looking at the string Tacoma, the letter capital T is at position 0 in the string. The letter A is at position 1 in the string. The letter C is at position 2 in the string, so on and so forth. Okay, so each of these letters has a corresponding position. In computer science, we always start at 0. Okay, so here I'm saying city.char at 0. It is returning back a character. I am storing it then in a local variable of type char, and then I print it out. So you should pause. What do you think will print out? Substring. Substring is a method that takes in 2 positions, and it will kind of do what it says. It will return a substring that starts at the specified first index, and it extends to, and this is a little not obvious, if the substring extends to 1 minus this second index here. So this is saying, give me the substring that starts at character 0 and goes all the way to not 4, but 3. Similarly, this is saying, give me the substring that starts at the character in position 2 and goes all the way to not 6, but 5. Okay, so this is giving you characters 0, 1, 2, 3. This is going to give you the characters in position 2, 3, 4, 5. That's the substring it's going to return back. I'm storing each of those in a string local variable, and then I'm printing them out. You should pause and make a prediction as to what you think is going to print out. The next method that you have access to is the equals method. This returns true if this string, whatever our reference variable is pointing to, and the other string that is being passed in contain the same sequence of characters. Okay, so here city.equals Seattle is kind of a question. We're saying, does this string equal this string? There's also another equals method, which is equals ignore case. This one will return true if this string and the other string contain the same sequence of characters, regardless of capitalization. So I have kind of a funky capitalization scheme here. I'll just give you the answer. This is going to return true. Okay, so equals and equals ignore case return a Boolean. This would return true. If, however, I had said city.equals Tacoma with some funky capitalization, that would return false. Okay, so capital T-A-C-O-M-A is not the same as capital T-A, capital C-O, capital M-A. They have different capitalization, thus they are different strings. They're in different states. There you go. Okay, so I told you the answer to that. This is going to be true. If we ignore capitalization, they are the same string. On the same note, there's a method called toUppercase. This will return back a new string that is identical except everything is uppercase. Similarly, toLowercase will return back a new string except everything is lowercase. Again, you should stop the video and predict what you think will print out. These methods are a little bit more obvious. Replace, there's a replace method. So I could say city.replace. This method takes in 2 characters. And you're saying, please replace every instance of the first character with the second character. This will go through the string Tacoma, and it will replace every instance of a lowercase a with a capital X. Don't know why you'd want to do that, but you can. Okay, last but not least is a very useful method called index of. This takes as input a character. In this case, I'm passing an A. What it's going to return is an integer. It returns the position of the first occurrence of that character in the string. So this is going to tell me the position of the first lowercase a in the string Tacoma. Now, if I had said index of and passed in a question mark, it will return -1 because a question mark does not occur in the word Tacoma. Okay, so it's either going to tell you where the first occurrence is or it doesn't exist with a negative. Okay, so you should go through and kind of predict what you think each of these is going to print out. I'm going to actually run it now. And then you can check your answers. Okay, so here you go. And I'm not going to explain any of these. So, okay, let's move this so you can see a little bit better. If any of these answers is surprising, you should stop and go back and look at the code and kind of explain or kind of figure out why the answers are what they are. Okay, so here's each of those print statements shown. Okay, a few last things I want to comment on. This example here is showing why we only need one operator. With the dot operator, it allows you to access the multitude of methods that live within the string class, such as length, char@, substring. There are so many more methods. So we really only need one operator because we just have a lot of really great methods. 2, where is this coming from? We did not write the string class. Someone else wrote a class called string. It lives on your computer, unbeknownst to you, in a file called string.java. If you were to open up that string, you would see all of these methods defined. In the same way that we talked about how do I define a method, everything we talked about applies here. So someone sat down, they created a string class, and then they put a bunch of methods, right? Public, int, length, and then they wrote the code. Public, char, char@, It takes as an input a single integer. So we are relying upon code written by someone else. That's one of the great things about reference variables is literally, no joke, there are hundreds, if not thousands of classes that other people have written that we now have access to. As soon as you know how to use a reference variable, and as soon as you have access to code other people have written, string is just the beginning. We're going to look at random, we're going to look at scanner. There are so many types of classes out there that you can use once you know how to use reference variables. Okay, last but not least, how do I know what methods live inside of my string object? How did I know this? To uppercase, to lowercase. It seems pretty important that if someone else wrote some code and they added a whole bunch of really cool methods that I can use the dot operator to call, I probably need to figure out what are those methods so I can use them, okay? So there is something known as the Java API or the Java documentation. The easiest way is to just Google Java string. The name of the programming language is Java and the class we're interested in is string. This will pull up this docs.oracle.com, which is the documentation page for Java. If you click on it, this website summarizes everything about the string class. At the beginning, it usually provides some examples, kind of explaining what is this class and how do you use it. Then it shows you the different constructors. There are a lot of constructors. We saw one constructor, string, parentheses, pass in, whatever string. In reality, there are so many constructors you could use. We will never use any of them, but the one we saw. Okay. Then these are all the methods that live inside the string class. There are a lot of them. Okay, there's a lot of methods. This table tells you how do you use each method. So for example, here's char at. This here tells you the return type. So if you call this method, it returns back a char. The method's called char at. It tells you the input. You need to pass in an integer. You can even click on it and it will give you much more information. So it will tell you what it returns. It'll give you kind of examples of how to use it. So basically in Java, when you create your own class, you also want to write a lot of documentation so that people using your class know what methods do they have access to and how to use those methods. We will talk all about that in a few weeks, okay? So I just wanted to let you know, I did not memorize all of these. Well, I have at this point, but you don't need to memorize them. There's a web page and it tells you all about that. Okay, looking a little bit forward to the future, in the next lectures, we're going to look at two more classes, the scanner class and the random class. Together with scanner, random, and string, you could do some pretty cool things. In particular, we will start writing interactive programs, so that's going to be really cool. Okay, so let's go back and just do a quick recap. Primitive variables store literal values. If that was all we could use, programming would not be nearly as fun. But there are these things called reference variables. Reference variables store memory addresses of objects. That's why they're called reference variables. They reference or refer to objects. The big million-dollar question is why? What's the benefit of doing that? Please come to class with at least one idea or one thought on why reference variables are useful. How do you actually instantiate an object? The left-hand side here is kind of, business as usual, string name. The right-hand side, though, the actual initialization or instantiation for a reference variable, for an object, is a little bit more complicated than it is for a primitive variable. You should understand the 3 steps that are happening here: the new keyword, the constructor, and ultimately what is returned. Going a little bit deeper on this slide, I was just trying to give you a little bit more of a sense of what is an object, data and methods together. Again, take what you can take, leave what you can leave. We're going to come back to this idea of objects and data and methods again and again. And I really believe it kind of takes all semester before you have an epiphany and you're like, I get it. I get what an object is. So this is your first exposure. We'll come back to it. Okay, now that you have a reference variable, now that you have an object and you can point to it, what do you do with it? Literally the only operator you can apply is the dot operator. It seems really limiting, but the dot operator allows you to access the multitude of methods that live inside your object. You should, this code will be posted, you should really go through, make sure you understand how I'm using the dot operator to call methods, because your homework assignment on this is kind of heavy duty and it really requires you to understand the use of the dot operator. Okay, so here's me giving examples of how to use methods inside the string class. And then last but not least, I did not memorize those. There's a lovely documentation page. For you, it might be a little bit technical. You kind of have to get used to the language, but once you're used to it, you can kind of just look up any sort of method and be like, huh, what does this do? And as long as you pass in the appropriate input, and as long as you store the return value in an appropriate output, you can call whatever method you want. In fact, I kind of encourage you, just go through and start, I don't know, look at some of these methods, call them, see what they do, and have fun. Okay, that is that, and we're done.